Private LLMs are easy to spin up and great for narrow tasks. Some of the most impactful use cases of private LLMs are for highly sensitive data when you're dealing with it. Let's say you're asked to redact sensitive data from thousands of customer emails before sending them to a third party. You can't use OpenAI or ChatGPT for this because that would breach GDPR, but the task occurs regularly enough that it makes sense to automate it. This is where you can use an inference server like vLLM to create your own private LLM server, giving you complete control over your data. With the right software and hardware, you can set up a private LLM fairly quickly. However, if you want this to be production worthy, meaning it can serve as an internal LLM for large workloads in an enterprise environment, I'll cover what you need to go to production at the end of the video. For now, I'll walk you through setting one up live from scratch in 10 minutes to show you the basic principles. This isn't intended to be a step-by-step guide. I have plenty of those already if you scroll through my previous videos. I just want to give you a flavor of what it's like to get these private models up and running. Ultra low. So let's call it ultra simple spec template. This is an ultra simple spec template, and I asked ChatGPT to create this ultra simple spec template. Let's see what. So goal. What's the goal in one sentence? So we building a private LLM inference. What's the goal? Always a private, locally hosted LLM inference endpoint with a chat UI. That's what we're building. Main features, inference server, which will be vLLM. vLLM is a high throughput inference server. So the inference server is the thing that allows your LLM to run. You can think of it like the engine. There's the hardware part of it, which is the GPU, and the software part of it, which is the inference server. The main features you have is the inference server, and then you have, what else? Chat UI interface. It should just be a simple input, output, no memory required. So I'm saying no memory required to keep it simple. We just want it to be, you send a message to the endpoint and the endpoint responds with the response from the language model. So data, we're not storing any data. What it stores or loads locally. So JSON, CSV, no loads. So we'll put that in there, completely stateless. Okay. And flow, how the user moves through it, e.g. open, edit, save. User opens browser and the chat interface appears. User and for chat is refreshed. User refreshes page. So that's it. User opens browser and the chat interface appears. User chats back and forth. Chat is refreshed when the user refreshes page. Okay, so tech stack, let's just go with Python, and I wonder what the easiest front end framework is to work with a Python backend. What's the easiest front end framework for Python backend? So there's a few suggested here, but actually I want one that is just good for chat. So for a basic chat interface, it's best for a basic chat interface. So Streamlit, yeah, Streamlit's okay. Streamlit's all right. Yeah, maybe I'll go with Streamlit. Cool. All right. So let's do tech stack. Let's do Python backend. Streamlit for front end. I have found Streamlit a bit of a pain to get started in the past, to be honest with you. I have found it a bit of a pain. But let's get that done, and we're operating on, this doesn't matter, really. This doesn't matter. Oh, yes, it does. Okay. So technically, it's on WSL, technically. So Codex is my choice of LLM, and I am going to, or my choice of coding agent. Yes, allow Codex to work in this folder without asking for approval. Yes, go ahead. So I set the model to high thinking for everything, and approvals I always set to auto. So there's read only, and then Codex requires approval to make edits and run commands. But if I'm doing a kind of a new little script like this, something small, it's okay. Codex can run in auto mode. Hopefully. Maybe it's because it's on the overthinking mode. Let me see if I take the model down to a lower reasoning effort. Let's go with this, and let's drop that down to balance of reasoning depth and latency for balancing speed with reasoning useful for straightforward queries or short explanations. So let me see what the medium does. So I've just asked it to step it up a bit of a higher level and give me the activities required. Because yeah, maybe if you say tasks, it's going to break it down like security, environment files, all of that type of stuff. I don't really want it at that level. I want it at a higher level than that. So we've got the setup. So create folders, initialize Python 3.10, add, git, ignore. Yeah, sounds about right. Implement to load. Yeah, that's all configuration stuff. Yeah, vLLM base URL. Fantastic. Streamlit UI. Yeah, on submit. Integration with a minimal call to vLLMs open the AI compatible. Yeah. Yep, that's right. OpenAI is compatible endpoint. That's what we want. Send a single user message. Return first assistant message. Handle simple errors. Yeah, rank. Make file target to. That's fantastic. Let's follow what the agent does. Saved, file created, tasklist.md. Want me to scaffold the files next and add a minimal make file target chat? Yes, but let me understand this. Is it creating the environment setup? Because I told it yes. So I'll scaffold a minimal Streamlit app and conda aware makefile. I'll add an environment.yaml for anaconda.m. Okay. Okay. Requirements. Don't need OpenAI. Do we? I guess for the endpoint we do. Okay. Streamlit. Python.env. Here's the Streamlit app.py. Settings.py. Sorry. Yep, Streamlit app.py, settings.py. What's this doing? This looks familiar. OpenAI, vLLM base URL, that's what we want. So this is just a basic input-output function. It's not for production. This is just a quick script to make life easy. Okay. What have we got here? This is the make file. Okay, great. So what I think this will do is this will spin up our server in Streamlit, our little chat interface that will call our vLLM hosted server on the back. So yeah, that's for the chat interface. Next, I'm going to show how I'm going to set up that vLLM server for a private model. All right, so I'm getting us set up on vLLM, but before I do that, I'll just show you the result of all of that coding. So I have a very simple input output box here. And that's what I have. So a message will be submitted here and it will send it to the LLM on the other side on our inference server, and I'll get a response from the LLM. So I'm using RunPod. The reason I'm using RunPod is it's really easy to get up and running on a GPU with RunPod. You pay, I believe, by the hour for GPUs. And you can select NVIDIA. You can select even run on CPU as well. But in this case, I'm going with the NVIDIA GPUs because it's just easier. So I'm using the Docker image for vLLM. vLLM will provide the inference server, as I mentioned before. And then there's a few things that we need to put in place here. So there's a few arguments that we need to put in place. So container disk, volume disk. Right, so we're going to be running this IBM Granite model. And that's 1 billion parameters. I actually don't recall, let me see, because I don't recall how many gigabytes you would need for a 1 billion parameter model, but nowadays that type of information is not difficult to find out. So I'm going to pull up ChatGPT and give it an ask. I'll go with 10 gig. for the container this. So the container, so it's 10 gig. The volume mount workspace can just be called, let's just call it model. Yeah. And then we want to add some ports. So it's port 8000. Okay. And then we have some container start commands here as well. And I'm going to just bring those in. We have the model that we're using, which is the IBM Granite model. So that's the 1 billion parameter. Got our volume mount and all of that. So that all looks okay. So what I'm doing here, guys, is I am just creating an inference server. So imagine if you wanted to do this and you wanted it to be completely private, what you would need on your own laptop is a laptop that had a GPU, a sizable one. So this is probably going to be, I don't know, a 10 gig or above GPU on your laptop that has at least that memory available. I don't have that. I've got a laptop that doesn't have a large GPU at all. So I can't run any models really on the GPU. So what I'm doing instead is I'm just going to RunPod and renting a GPU to get my model set up and run. If you did want to do it locally, like I said, if you did want to do it 100% securely, you would invest in your own GPU. And instead of doing what I'm doing here, all you would have is a Docker file set up and the commands are put in the RunPod interface, which is effectively like creating a Docker file, but with a user interface on top. These commands are going to be executed by RunPod and it will stand up the vLLM inference server with the model I want behind it. And I can access that with an API call. So it's quite simple to get yourself up and running with a vLLM inference server just using Scaffolding. Great. So that's it. I'm just going to hit save. And pod is quite cool. You can see all the other templates I have running. RunPod is quite cool because what you can do is you can move over to pods, and here you get all of your GPUs and the hourly rate. So I want something very, very cheap. Let's see. I usually like to go to the older gen ones, but sometimes models break down on the older ones. So let's go for this 16 gig of video RAM, 20 gig of RAM on this machine. So that should be good enough to run our model. So this is the important figure here for us. The 16 gig of VRAM, that's what we need to run our model. Okay, and then you select one, so we're not doing multi-GPU inference because it's a small model. We'll do it on demand. Do we want to encrypt the volume? Couldn't really care less about that right now because we're just trying to get up and running quickly. I want to change my template to the one I created, which is the IBM one. It will load. Seems to be taking its time. Okay, let's see. I have a lot of templates. Private, that's the one I was looking for. Here we go. Great. So my template is set and I can go to deploy on demand. So that's going to go ahead and deploy the model behind an inference server. So that's pretty simple, right? Yep. So let's come back when I've wired everything up. I have deployed my endpoint on RunPod, so everything's up and running. The vLLM image compiled. Okay, so it's all good. You can see the container here with everything we need, and you can see the commands. So what I'm going to do is I'm going to attempt to connect us up to this large language model. So I'm going to grab the RunPod endpoint. I believe it was this one. Yep, so I'll grab that RunPod endpoint, and again, that's just where the API is located. That's where it's hosted. I'm going to replace that vLLM base URL with the RunPod endpoint v1, I believe. That's how we do it. And then I'm going to redeploy the chat app and see whether we're connecting up to our LLM. All right, so before I jump into the chat engine itself, let's do it for the use case we're talking about. So let's say we had a use case where we wanted to remove personally identifiable information, so PII stuff. And this stuff is so private that we can't send it out to OpenAI or Claude or Anthropic or anyone. We want to keep this completely on premises. So I'm going to ask Codex, can you add a system prompt to our model that makes it strip out any PII in an input? Okay, so let's see. I'm going to ask Codex to put that in place. Okay, so there's a user and there's a system prompt in there now. All right, And I'm going to redeploy the application, and let's see if we can have our little private PII filter. All right, so we have our system prompt in place. We have our inference server all stood up on LLM, which gives, all stood up with vLLM on RunPod, which gives us effectively a private model for the session. So imagine you are in a corporate situation, or you're in an enterprise situation, or a situation that requires a lot of data privacy, and you're told, hey, we need you to look through 1,000 emails and redact all of the personal information in there because we're afraid that there's been a breach or something along those lines. That might not be like a completely accurate scenario, but you get the point. You have to look for a lot of personal data and you have to redact information from there. And you can't send this out to the LLMs. You can't send this out to OpenAI because you cannot send that information to a foreign entity for processing. For example, you might be in the EU, for example, and you can't send that data out to America or have it sit on American servers. You have to be in complete control of where that data is. No problem. You can stand up your own large language model and you can actually get it to be able to perform tasks narrowly. So all you need in this case is a small model. I think it's 1 billion parameters. I've given it a dummy email with some dummy personal data in there, and I've just said redact all the personal data. So I'll send that across, and you can see the model just has one job, and that job is to redact that information. So we have the redacted information down there. Now, obviously, if I fine tune this a bit better, and if I set it up a bit more with a bit more thought and put a bit more time into it, the quality of this output would be better. But the point I'm trying to display here is you can get a private large language model stood up behind a private endpoint that you control. You know where the data is, and it can perform narrow tasks. And if you fine tune it well enough, and if you engineer it well enough and set the system prompts up well enough, though, it can perform those tasks to a high level. I mentioned at the start of the video, I would talk about what's needed for a real deployment in production. Before I dive in, feel free to reach out to BrainQ if you need advice on how to get private production-ready models up and running on your own servers. For real deployments, there would obviously be a number of additional steps beyond what I showed in this video. Security hardening, scaling, deployment architecture would all need to be considered. This is where you would write a proper spec and build according to that. But let's talk through some of the basic things that you would need. First, you'd want to authenticate the endpoint. You can do this easily by placing the vLLM container behind an API gateway of your choice. This helps prevent unauthorized access to your private LLM. You may also wish to rate limit the API to prevent overuse of GPU memory capacity and prevent crashes. The deployment environment would likely be one or more of the following. If you're fortunate enough to have access to superior hardware, you might be able to deploy the model straight onto your laptop. You might have GPUs on premises that you can access via SSH, or you might be renting GPUs directly from one of the hyperscalers, i.e. AWS, Azure, or GCP. Regardless of your setup, getting your server ready for production would require you to build the Docker container. You do this by installing Docker on the machine and then running Docker build commands, which would build the Docker container. It would build this Docker container based on the instructions set out in your Docker file. It's essentially the same thing as RunPod is doing, but without the user interface. The last step will be prompt engineering and fine-tuning. For many production use cases, you're likely going to be limited in GPU capacity. That's why you need to make smaller models work for your task. After picking the model, which you can do by looking at things like the model's performance and weighting it up against the size and memory requirements, you can then start with some basic prompt engineering and testing your model to see how well it performs on your outlined task. You can experiment with fine-tuning too if performance falls below your requirements. Just be aware that for high precision, high recall tasks, you probably won't hit your performance requirements out of the box without some tinkering, especially smaller open weight models.